And here we go. What we would like to do today is we would like to graph sine and cosine functions. Fix your grade. Graph sine and cosine functions, okay? For her last test, the last test was worth 48, and the first number, the tens place, I typed in the wrong number for, so kind of changed her grade a little bit. So anyway, all right, fix that. All right. So we all make mistakes, and there is forgiveness. Thank you. So here's where we at. We're going to graph sine and cosine functions. And what we have to do is we have to literally just take the values off of the unit circle. So what I want to do is I'm going to take y equals sine of x. I'm going to make a t-chart. X values, y values. I'm going to start with 0, pi over 6, pi over 4, pi over 3, and pi over 2. Now again, there's a lot of things to memorize in trigonometry. The fact is I don't memorize them. I always bring them back to the unit circle and the ways that we derive them. So I'm going to show you how to do that. We remember that? I don't know. So I take out my unit circle. It's handy dandy. And I look at it, and is sine the x values or the y values? All right, maybe got that part right on the test. Nice job. So I look at this one right here, okay? And I look at the y value. So what is the sine of 0? What's the terminal point of 0? 1, 0. So what is the sine? 0. Do you see that? What's the sine of pi over 6? Sine of 45. Sine of 60. And sine of pi over 2 is... Sine of pi over 2 is 1. Do you see those values? We are simply going around and finding the y values. That's what we are doing. So I go to my sheet, and I say sine of 0, you said was 0. Sine of pi over 6, you told me was 1/2, or 0.5. Sine of pi over 4, you told me was square root of 2 over 2, which is 0.7071. And sine of pi over 3 is the root of 3 over 2, or 0.866. And the sine of pi over 2 is 1. I'm going to leave it in decimal form for right now. Question. Okay, so I'm going to put it in decimal form because that way we'll be able to plot it. Now, let's look at our unit circle and make a conjecture about this. True or false? The largest value of sine in the unit circle is 1. Ooh, we're divided. What do you think? True, yeah, it's the largest value, 1. Doesn't get any higher than 1. True or false? The smallest value of sine is 0. False. What's the value smaller than 0? -1. It goes all the way down to -1, right? Look at what happens. Is sine positive or negative in this quadrant? Positive. How about here? Positive. And see how it oscillates between those values, like 1/2 here, 1/2 here. Then down here it's -1/2 and -1/2. Kind of spirals through all those values, right? I mean, it continues to move through those values all the time. Sine of 0 was 0. Sine of pi over 2 was 1. Sine of pi is 0. Sine of 3 pi over 2. And sine of 2 pi, 0. So let's start making our shape. You told me the largest value of sine was 1. The smallest value was -1. And you're really smart. It takes 2 pi for sine to completely repeat itself. Now, between 0 and 2 pi, we have 4 different quadrants where sine takes on different values. So I'm going to divide it up into 4 pieces. What's half of pi? Pi over 2. Now I'm going to count. 1 pi over 2, 2 pi over 2, 3 pi over 2. And now I'm going to plot some values. 0, 0. That was easy. pi over 6, how does that compare to pi over 2? It's a third of the way. So I'll go a third of the way and then up to 0.5. Pi over 4 is halfway. And then go up to 0.7. Oh, pi over 3, and then to 0.86, and pi over 2, I go up to 1. Kind of interesting, huh? It repeats those same values on the way back down, doesn't it? Like when we looked at the unit circle, we could kind of just say, well, it's going to kind of do those same pieces, right? And then the sine of pi was 0. Remember what the sine of 3 pi over 2 was? What is the y value at 3 pi over 2? Negative 1. And when we go all the way around 2 pi, what's the y value? 0. So that's why sine is that shape. Describe the shape. Describe the shape. What? It's a wave. Yeah, and that's important. Galileo said mathematics was the language with which the universe was created. And his idea was this: everything that we see in nature can be modeled mathematically. And in fact, when I am talking to you, my voice, how does it travel from my mouth to your ear? As a wave. In fact, we can write a sine function that models your voice as it travels. Light traveling from the projector to the screen here, same thing. We could model that wave as a sine function, okay? So those are all really important applicable pieces that we're going to see here. So as we look at the sine function from 0 to 2 pi in that interval, it has a maximum value of 1, a minimum value of negative 1. Its amplitude is how high or how low it goes from its axis of rotation, and that would be 1 unit as well. And the period is how long it takes for it to repeat itself or complete one graph, which is 2 pi units. And that is for the parent function of the sine graph. But we don't want to just graph sine, you guys. We want to graph y equals negative 2 sine of 3x minus pi over 6 plus 4, okay? That's what we want to do, okay? This is child's play. We want to do stuff like this, and we're going to do that tomorrow, okay? And if you can graph that tomorrow, you'll be capable of getting an A+ on this test. But if you can't learn how to graph these, you got no chance of graphing secant and cosecant. Let's move on to cosine. Cosine is very similar. And I'm going to go right back to our unit circle. Is the cosine the x values or the y values? X values. So what do you notice? Tell me something that's similar about the x values and y values, and then tell me something that's different. Okay, they kind of pair up. Like here you got root of 3 over 2 and 1/2, and then here you got 1/2 root of 3 over 2, right? So they kind of cycle through the same values, correct? But here, like the x values are positive in the first quadrant, but then they're negative over here, right? So whereas sine was positive, then negative, this changes a little bit, doesn't it? In fact, the cosine of 0 would be 1, whereas sine was 0. And the cosine of pi over 2 is, whereas sine was 1. And the cosine of pi is, whereas sine was 0. So that will help us generate these values. Again, this is simply the unit circle unwound and looked at visually. So I have y equals the cosine of x. I create an xy table. This time I'm going to use other values. I'm going to use 0, pi over 2, pi, 3 pi over 2, and 2 pi. Because you're really smart, you're going to tell me what the cosine of 0 is. 1. Cosine of pi over 2. 0. Again, we're looking at the x-coordinate of the terminal point. Cosine of pi. Cosine of 3 pi over 2. And cosine of 2 pi. So we will create some markings here. Zero, one. Pi over 2, 0. Pi negative 1. 3 pi over 2, 0. And 2 pi 1. And so we have that shape. What can you tell me about that shape? It's a wave. Very similar to sine, isn't it? In fact, every single cosine function can be written as a sine function, and every single sine function can be written as a cosine function. I just simply take this, move it up here. You can see how similar they are, right? If I simply shift it, they are identical. Were you yawning, or did you think that was cool? Okay, because I thought it was a yawn there for a second. You wouldn't ever yawn in this class. Okay, all right. Well, I didn't think so, but all right. Okay. Okay, here we go. Amplitude, okay? Amplitude. If I have, today we're just going to do A and B. Tomorrow we'll add on horizontal shift and vertical shifts to this piece. If you want to know the amplitude of the sine function, amplitude is always positive. You simply take the absolute value of the number in front. Same thing for cosine. The period starts off at 2 pi, but then you divide it by the b value, whatever sits in front of the x. The very last sheet that you have in your notes. This is your Lifeline sheet. This is what you get on your test. Do you see it? Look at the sine and cosine. It says amplitude's absolute value of A, period is 2 pi over B. I can give you those pieces. You can see the other piece that you're given as well. You're also given the parent functions. So that's your kind of your lifeline to be able to reference if you can't figure stuff out. Okay. What? No, it's just, everybody has a different sense of humor. And so we're going to pretend that we have the same sense of humor so you guys feel validated, right? You guys? Ha 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 ha. Okay. Okay, all right. Now the head goes to the hands. All right, there we go. All right. Thank you, Kayla and Carson, for adding joy to our lives. All right. Okay, here we go. Cross off those two. I won't say the numbers, otherwise you'll laugh. Determine whether the following graphs have a parent function of sine or cosine, then determine amplitude and period. A for the day, what's the amplitude? 4. The period is equal to 2 pi divided by the number that sits in front of x. So it's 2 pi. 2 pi divided by the number in front of x. So since there's a 1, yep. Okay, 5, what's the amplitude there? 2, it's always positive. I will take points off on the test if you write negative. The period, still 2 pi. 3, or number 7, what's the amplitude? 3. The period, I take 2 pi and divide it by 2/3. Oh no, fractions. Mr. Giddens, I hate fractions. 2 pi over 1 divided by 2 over 3 multiplied by the reciprocal, and you get 3 pi. Number 8, what's the amplitude? 4, what's the period? 2 pi over 5. Okay, so you can see different examples of the period and the amplitude. Let's try a graphical representation. We're actually going to write equations for these 4. Let's identify first whether it's going to be a sine graph or a cosine graph. First one, a sine graph or a cosine graph. Why? Starts at 0, 0. What's the amplitude? What's period? Meaning, how often does it repeat itself? How long does it take before it completes one cycle? Would you agree that between 0 and 2 pi, it has completed 2 cycles? So therefore, its period is pi. Now, in order to write an equation, you need y equals a times sine of bx. We know that the a value is going to be 3. Question. Because it starts at 0, whereas this one starts up at 4, so that will be a cosine. Because sine from our parent function says it starts at 0, and cosine doesn't. Good question. Thank you for asking. Now, I need to identify what the b value is, and we have a formula. 2 pi over b is equal to the period, or pi. Cross multiply. Pi times b is equal to 2 pi. Divide by pi, and you get b is equal to 2. So your function is y equals 3 sine of 2x. That's the equation for your graph. What do you think? Does that seem reasonable? I want you to see a quick way to generate these as well. The number that goes in front of x is the same as the number of cycles it completes between 0 and 2 pi. Okay? So how many did it complete? Okay, works out pretty well. Sine or cosine? Cosine. Amplitude. 4. Period. That's 1 cycle, right? That's 2 pi, right? So my equation would be y equals 4 times the cosine of how many cycles? 1 cycle within 2 pi, so just cosine of x. Yo. Okay? As we look at this, I just have to look at when it kind of gets to a point where it, the cosine graph, the shapes that I'm drawing in black, red, and blue are 1 cycle of the cosine graph. So it starts at 0, and it makes its full completion by the time it gets to 2 pi. So 1 cycle in a distance of 2 pi. 2 cycles in a distance of 4 pi. 4 cycles in a distance of 8 pi. So that leads us to say that every 2 pi, it repeats itself. Okay, let's try another one. Sine, cosine, sine of x, because it starts at 0, so we're going to call it sine. Now the sine graph, that would be 1 cycle, correct? So how long does it take to complete 1 cycle? It takes 4 pi. Very good. What is the amplitude? 2, and the period, as you said, it takes 4 pi for it to complete itself. So how many cycles is that in 2 pi? A half of a cycle each 2 pi, right? So this will be a y equals 2 sine of 1/2 x. Sine or cosine? What's different about this? It's upside down, and when things flip upside down, what do we put in front? a negative. What's the amplitude? 5. But you're right, we will put a negative 5 in front, and then the period is 2 pi. So it completes one cycle in 2 pi. So therefore, we have y equals negative 5 cosine of x. Yes. Right. Okay, let's look at some equations that are a little bit more difficult to identify amplitude and period. Some are easy, some are not. Amplitude for A, 2, period, 2 pi over 3. That's its period. How many cycles will it complete within 2 pi? It will complete 3 cycles within 2 pi. It will repeat itself every 2 pi over 3. B, amplitude, period. Uh-oh. Two pi divided by, what's the number in front of x? 1/4. Dividing by a fourth is the same as multiplying by 4, so you get 8 pi. C, what's the amplitude? 1. What's the period? Take 2 pi over 1 and divide it by 2 pi over 5. Multiply by the amplitude. Period is 2 pi divided by pi, which is good. Okay, let's try to graph these. We go to 1 or 105. 1. All right. We're going to skip one of these. We'll skip this one. Okay. Negative sine of x. I'm sorry, but for some reason, these don't seem to pop up the way we want them to. Let's draw some in here. Okay, so what's the period? Or I'm sorry, what's the amplitude? 1, and the period? 2 pi. So when you graph these, what you'll do is you'll mark off the amplitude, 1 and negative 1. I will ask you to provide one period on each side of the graph. Then the best way to go about this is to identify where it starts. If it's sine, is it could start middle, top, or bottom? Middle. And where's it going to go? Is it going to start by going up, or is it going to start by going down? Up. And after it gets up to 1, what's it going to do? It'll come back down. It has to cross over 0. And after that, it's going to go to all the way down to negative 1. And after that, it'll come back up to 0. And then you can do the reverse fashion the other way. You can see, yo. Whoop, I'm sorry. I didn't make that mistake. You didn't make the same mistakes each other. That's all right. Okay, so it's sine, and sine generally goes up. But because it's negative, instead of going up to 1, it will go down to negative 1. After it's down negative 1, then it will come back up. there's our function. Okay, next one. Y equals 4 sine of pi x. What's the amplitude? 4. And what's the period? 2. What's different about this one? Okay, positive, and there's no pi attached to the period, and that's fine. So 4 for my amplitude. Where's it going to start? And it's going to go up. Then you can also go in reverse order. Amplitude. 2. Period. 2 pi divided by what? 1/3. What's 2 pi divided by 1/3? 6 pi. Mark off 2. What's half of 6 pi? What's half of 3 pi? Pi over 2. Now watch me count. 3 pi over 2. 6 pi over 2. 9 pi over 2. And 12 pi over 2 would give me 6 pi. So I come up with the values. Negative 3 pi. Where do I start? And from there I go. Then. We'll check that out right now. So, amplitude for this one is 2. The period. Amplitude for the second one. And the period. 2 pi over 4, which is pi over 2. So here's what I would encourage you to do. I would encourage you to take the largest amplitude, so 6, and mark that off at top and bottom. Notice how I'm choosing to use 2 for my tick marks. And I would encourage you to choose your largest period, so 2 pi, and mark that off. We won't get to the last example today. We'll have to do that tomorrow. But I do want to get through this and give you your assignment and graph it in the calculator. So let's start with our this one right here, okay? Because it stretches all the way out to 2 pi. Where is it going to start? Is it going to start by going up or down? Down. And what height is it going to be at pi over 2? Negative 2. Do you see how this looks different than our previous ones? How is it different? And it looks smaller, doesn't it? That's because we're placing it on a different set of axes. Look at our next one. I go up to 6. The period is pi over 2. So what does that mean? It means I have to take pi over 2 and divide it up into 4 pieces. Where's it going to start? 0, 0. And then it will start by going up to 6. And then 0, 0. And then negative 6. And then back to. So do you see within each tick mark, I need to complete a full cycle, don't I? So I'll draw it to the best of my ability. Now, you might choose to laugh at this, but did I take out my calculator? You can always check these by looking at a graph. I type in negative 2 sine of x. By the way, your calculator must be working in radians. Working in radians right now. 6 sine of 4x. If I take my window and I choose my x minimum to be negative 2 pi, my x max to be positive 2 pi, and my scale to be pi over 2, and my y min to be negative 6, and my y max to be positive 6. I got a scale of every 2. Watch my graph, and you tell me if you think I did a good job of graphing these or not. That's pretty ridiculously accurate, isn't it? So tomorrow we'll pick up with the second example. You have an assignment in the meantime.